Let's imagine the unthinkable. A nation decides to drop a nuclear bomb, not on a city, not on land, but deep beneath the ocean's surface. Specifically, at the very bottom of the planet's deepest point, the Mariana Trench. What would happen? The Mariana Trench plunges nearly 11 kilometers into the Earth's crust. That's deeper than Mount Everest is tall. It's dark, cold, and under crushing pressure, over 1,000 times what we experience at sea level. It's a place that barely tolerates life. But what if we introduce something far more violent into this fragile abyss, a nuclear explosion? Suppose, for the sake of this thought experiment, we use the most powerful nuclear device ever detonated, the Tsar Bomba. At 50 megatons, it's over 3,000 times more powerful than the Hiroshima bomb. Now imagine we manage to place this bomb into a specially designed capsule, resistant to deep-sea pressure, and lower it all the way to the bottom of the trench. And then, we detonate it. The initial detonation would be anticlimactic. Why? Because water is incredibly good at absorbing energy. Unlike air, which allows fireballs and shockwaves to expand violently, water resists. So while the bomb would generate an intense release of energy, the resulting fireball would collapse almost instantly under the immense pressure. A huge shockwave would ripple outward. But the trench, like a deep scar in the Earth's crust, would absorb much of that force. At the surface, ships and satellites might detect a tremor, a disturbance, but no tsunami, no epic water column exploding into the sky. In fact, the surface of the ocean might barely ripple. So, no Michael Bay-style explosion. But there would be consequences. The detonation would vaporize all life within hundreds of meters. Microorganisms, deep-sea fish, and crustaceans, many of them not even discovered by science, would be erased in an instant. An entire pocket of unique biodiversity would vanish. Then there's the radiation. Nuclear fallout in the ocean behaves differently than in the atmosphere. Radioactive particles would bind with sediments and slowly settle. Some would be absorbed by marine life, others would circulate through deep ocean currents, eventually making their way into the broader food chain. Tuna, salmon, maybe even your dinner plate years later. And what about triggering earthquakes or tsunamis? Despite Hollywood's best efforts, nuking the Mariana Trench would not cause the Earth to split open. The amount of energy needed to trigger tectonic movement far exceeds even the most powerful nuclear bomb. However, if the bomb were placed near a fault line, especially one already under stress, it could potentially act as a catalyst. An earthquake, perhaps, a small one, but not the apocalyptic scenario we might fear. Now, let's take it a step further. Some have asked, could we use nukes to plug the trench and seal off carbon or waste, or even trigger volcanic activity to generate energy? The answer is mostly no. The geology of the trench is not a simple plug and play. It's dynamic, alive. Tinkering with it using nuclear devices would be like trying to fix a crack in your wall using dynamite. Usually you'll create a keen plota beater. Ultimately, the Mariana Trench is not just a hole in the ground. It's a gateway into Earth's inner geology, a pressure cooker of secrets we barely understand. To bomb it is not only dangerous, it's tragically short-sighted. The real danger is not the immediate explosion, but the precedent, the willingness to weaponize parts of the Earth we don't fully understand. And in the end, the scariest part isn't what would happen if we nuked the Mariana Trench. It's that someday, someone might actually try.